Alright, this video is going to be on graphing a horizontal launch scenario. I'm going to be doing this example for you. You guys are going to be doing a different example for me. But the graphs are going to look very similar because the horizontal launch scenario, all the graphs look the same. It really will just be your scale that is going to be different. So I picked the lunch pail problem number 7 and 8 from yesterday's work. And I'm going to write my t-chart here and figure out some of my other variables. So my initial velocity in the horizontal was 1.5 meters per second. My initial velocity in the vertical is 0. My acceleration is negative 9.8 meters per second squared. And what else were we given? A displacement of 250 meters. All right, we need to find our time because we need to know what the horizontal scale should be. And we also need to figure out our displacement, right? You guys should have done this yesterday. So if I want my time in the vertical direction, I'm going to use my modified kinematic to solve for time, multiply both sides by 2, divide by g, take the square root to give me my time. So that would end up being 2 times negative 250 times negative 9.8. Take the square root. So let's see what that is. That gives me a time of 7 seconds. I'm going to round. So now I have my scale for my y-axis. 7 seconds, 7 seconds. And I know this is for my time. I know for my displacement, right, the modified equation for your horizontal is x is equal to v times t. So x is equal to my velocity times time. 7 times 1.5 gives me 10.5. So my displacement is going to be 10.5 meters. All right, so now we have our stuff for our scales. I'm going to do my horizontal graphs first because they're a little more straightforward. So graphs. So I'm going to make a velocity time, an acceleration time, and a displacement time. I'll do my displacement time first. And if this is our building, right, it went 250 meters down. We decided it went 10.5 meters across. And its motion was something like this, right? We had a very small initial velocity of 1.5 meters per second. So my axis for my graph should be 11, 10, 9, 8, 7, 6, 2, 1, 0, and it should be 7 for my time. 1, 2, 3, 4, 7 for my time. This is time in seconds. This is horizontal displacement. I'm moving in the forward direction, so my displacement is going to be positive. So we can use our equation here to find our displacement at time 1, our displacement at time 2, our displacement at time 3. So our displacement here at time 1 is going to be 1.5. At time 2, it's going to be 3. At time 4, it's going to be 4.5, and so on. Right, all the way up to my 7 seconds. So I'm going to go over 1, up 1.5, over 2, up 3, over 3, up 4.5, over 4, up 5 and 6 over 5, 7.5, 6, 9, 7 should be 10.5. There we go. So my line, I need a straight edge. Right, my slope should be a steady slope because I am moving with a constant velocity, right? This position time graph tells me I'm moving with a constant velocity, which is true. In the horizontal, you have no acceleration. So for my velocity time graph, in the horizontal, I need 1 through 7, and then my vertical can just be the 1.5, right? Because 1.5, 1.50, because 1, 2, 3, 4, 5, 6, 7. Ooh, that was close. My velocity stays constant. So this is the scale for my velocity in the horizontal. And this is time in seconds, right? This velocity is in meters per second. So it's a steady horizontal, right? And there's no acceleration here, so my slope on my velocity time graph should be 0. All right, and then my acceleration time graph, since there's no acceleration in the horizontal, 3, 4, 5, 6, 7. Acceleration is in meters per second squared. Time is in seconds. It's 0. It's 0. So let me get a different color so you can see what that line would be, right? Right at the 0, because there's no acceleration there. For my displacement graph, and these we'll do vertical,